the previous videos we discussed about the trigonometric ratio of the sum and the difference of the two angles, and here is a question, a proving question. Actually this is a result, you can say, a kind of a trigonometric identity or formula that we can use further while proving or while solving many types of the problems of trigonometry. So here the question is sine a plus b times sine a minus b is equal with sine square a minus sine square b is equal with cos square b minus cos square a. This we need to prove. All right, so we have already learned the formula of the sine a plus b and sine a minus b, means we need to simplify it. All right, so first we need to write the left hand side. So let's start with our left hand side, and we need to get this part and this part one by one. All right, so let's first sine a plus b, all right, times sine a minus b. Now see, there is no trick, simply we can proceed this because we have already learned the sine a plus b formula and sine a minus b formula. So what we are going to do, we're going to just put the value of sine a plus b and sine a minus b. So let me put the formula for the sine a plus b. For formula for the sine a plus b is sine a cos b, right, cosine of b, and then plus cos a sine b. All right, this is the formula for the sine a plus b. And now I'm going to put the formula for the sine a minus b, and the formula for the sine a minus b is it's same, but the sign will change. That's it, sine a times cos b, and initially the sine was a and cos was b. Now the cos will be a and the sine will be b. All right, so minus, now you can say sine b, or you can first write cos a times sine b. All right, that's it. So now if you see here, one thing you can see, this is sine a times cos b, and this is cos a times sine b. All right, so this quantity and this quantity is same. Similarly, if you look, this quantity and this quantity is same. So don't you think it is looking like a minus a plus b times a minus b? So I can write like a square minus b square. So this whole quantity will be working as a, and the quantity, this one, will be working as a b. So I can write that square of this green color minus square of this red color. All right, like that. So here in green color we have sine a times cos b, all right, the whole square, minus now in this red one, so we have cos a times sine b. Now we can square, so it will be sine square a times cos square b minus cos square a times sine square b. All right, now everybody can say easily by looking this, we need to prove that it is sine square a minus sine square b, means there is no presence of cosine. All right, so we need to remove this cosine, and to remove this cosine we have a very simple way. What we had learned in the early stage of trigonometry, that sine square theta plus cos square theta equals to 1. So I can write easily that cos square theta is equal with 1 minus sine square theta. All right, so instead of this cosine square of b, I can write easily it is 1 minus sine square b. All right, so that now my cosine has been converted to b. All right, and all the things is going to convert just in the form of sine. And now here I don't need this cosine, so I need to convert this cosine as a 1 minus sine square a, and I need this sine. All right, so I'm putting here sine square b. So what I'm going to do now, I'm going to just multiply. I'm just going to open the bracket, so I'll get here sine square a minus sine square a times sine square b, and this is b. All right, and now minus will multiply, so minus and sine square it is, so this will be minus sine square b minus sine square b, and now this minus and minus will plus. All right, and sine square b, sine square a. All right, it's sine square a times sine square b. All right, and now look at the whole statement once. All right, see here, minus sine square a sine square b and plus sine square a sine square b. So I can cancel these two terms, and I will be left with sine square a minus sine square b. This is our middle side, This is our middle side, we proved. All right, and now we need this thing into the cos square b minus sine square a. All right, so we have again the same concept. We need the sine. All right, so from here now I need to convert this sine into the cosine. So what I can write, instead of sine square theta, I can write 1 minus cos square theta, just like this. All right, so I'm going to replace this sine square a by 1 minus cosine square of a. All right, and minus, or I don't want to put the bracket, minus sine square b. All right, sine square b is actually if I replace by the sine, then it will be 1 minus cosine square of b. All right, and it is inside the bracket. All right, and when this minus will multiply inside, and when I will remove the bracket, this quantity gonna be positive. All right, and this plus 1 and this minus 1 will cancel up, and I will get here now cosine square b. All right, cosine square b minus cosine square a, and that's my right hand side of the given proving thing. All right, so this is how we convert it, you know. So to do the proving problem in this second level of trigonometry, we need to use the identities that we learned in the early stage of trigonometry, you know, simple identities we need to use, and the recent formula that we learned. The recent formula we learned about the sine a plus b and sine a minus b. I mean the trigonometric ratios of compound angle, you can say, like of two angles, sum and the difference of the two angles. All right, so keep all the concept. All right, there was no more I mean there was no trick at all. We just put the value of this sine a plus b, sine a minus b. All right, everybody can do this if they have learned this thing. All right, so after learning the trigonometric ratios of sum and the difference of the two angles, we do these kinds of problems. So I just put the values, and I saw in the question, the thing was only here, I saw in the question I need to prove everything into the form of sine. So what I did, I just converted my all cosine into the sine. That's it. And when I converted, I got the middle hand side. All right, middle side. And once I get middle side, I need to get again in the cosine form. So what I did, I just converted this sine trigonometric ratio into the cosine by using the early stage of trigonometric identity that we had learned, sine square theta plus cos square theta equals to 1, and then we got the answer. All right, that's pretty easy. I hope you understand it, and similar type of lot of question you need to deal. All right, so see you in the next video with next question. Goodbye.